Hi, my name is David Plant and thank you very much for joining me today. I'm the Global Product Manager for Angus Fire for all of our firefighting chemicals, and what we're going to do today is talk through the sort of landscape, the legislative and the fire performance landscape of firefighting foam. So in order to understand where we're going, we first need to look where we are now. So obviously we've got coronavirus that's rattling around the world, but we've also got some trade wars going on. So we've got a China origin tax for products going from China into the USA. Like I say, Brexit is still being negotiated today, but should be sorted or thereabouts by the time this goes out. We've seen a massive shift in the energy mix. We've seen oil and gas companies start to transition to being energy providers. The low oil price of 2020 and the sort of the tumultuous times has sort of driven a much faster transition across towards renewables. We've got the European Green Deal and the chemical action plan that comes with that, which basically means the use of problematic chemicals is going to become more and more untenable going forwards, not just in fluorinated products, but all sorts of different chemicals. So going and looking at fluorinated compounds more specifically, so looking at firefighting foams and things like that, the European Union has now put together some definitions. So you can see the blue bar at the top, that PFAS, this is all of the fluorinated compounds, all the fluorinated chemicals. So this is the individual species that we've talked about before, the PFOAs, the PFOSs and things like that, as well as the groups, the C8s and the C6s, across every single use. So this covers firefighting foam, it covers cosmetics, paper, surface treatments and things like that. So all of the fluorinated compounds are in that top blue bar. The red box, the C8, so these are all of the C8 compounds, so obviously the most well-known being PFOA. The European Union has got active legislation that came into effect this year that now regulates these compounds in firefighting foams. The orange box, the C6s, there's a new definition the European Union has put together, which limits PFHXA. So that's the next one that's going to be started to be sort of talked about moving forwards. So those are all the European sort of definitions, if you will, but there is no definition for fluorine-free foam. So none of the international standards, the NFPAs, the ENs and things like that have brought together an actual definition of what a fluorine-free foam is, and we'll have a look at that in a bit. So moving forwards to the actual legislation that's in place today. So the C8s, like I said, it kicked in July of this year. And it basically means that a C8 product, a C8 PFAS product, can no longer be used for testing or training. That's a legal mandate across all of Europe. Any stockpile of these products needs to be tested, needs to be reported by July of next year. So this is different environment agencies actually tracking product use, product containment, and things like that going forwards. Moving through into 2022, C8 PFAS foams can no longer be used where they can't be 100% contained. So any kind of municipal application, certain process areas and things like that within refineries, those uses might become restricted moving forwards if they can't be captured and contained. As soon as that use becomes essentially illegal, then all of those foam stocks have to be sent away for high temperature destruction, and that has to be done by mid-2023. In 2024, the use of C8 PFAS products gets banned completely through all member states, and then users have got until 2025 to actually send those stocks away for high temperature incineration. So it's quite an aggressive move away from those C8, those long chain fluorinated firefighting foams. Now obviously with Brexit, HSE UK has said that any law that was passed during the transition period will take effect within the UK. So these rules and regulations also apply to UK users. So let's see what that looks like on a much larger scale. So you can see here 2020, all of the red boxes. So those are all the C8 PFAS sort of trigger points that I just talked through then. And you can see those moving forwards. Now the important point is that fluorinated surfactants are still permitted to be manufactured. The grey bar you can see coming out of the fluorosurfactant box at the top there. Now with the C6 legislation that's due to come in, around the 2023, that will actually ban the manufacture and sale of fluorinated surfactants going into firefighting foams. Potentially it would also ban the production and sale of the firefighting foam itself, although some uses of the product will have exemptions moving out over a longer period. You can see that tanks over 500 square meters have an exempted use going quite far into the future. However, that's still being discussed at the moment at the European level with various different stakeholders and user groups. And the blue boxes you can see there is the all PFAS legislation, which is due to come in at around the 2025 date. Now, this one will ban or restrict, severely restrict, the use of firefighting foams throughout all member European states. Now, the important thing to note here is that the European legislation will actually impact the production and sale of the fluorosurfactants, which will have a global knock-on effect to the supply chains. So what does C6 mean? If people are moving away from the C8 products and they're transitioning to the C6s, what do we actually mean when we talk about a C6 product? Now, it's important to remember that C6 is still a PFAS. It's still persistent in the environment, and they contain all manner of different chain lengths. So these aren't pharmaceutical grade products. They are industrial products, and there will be some different chain lengths in there that comes through from the fluorosurfactant manufacturing process, not from the foam manufacturing process itself. So the C6 does not contain just C6. So this definition of C6 purity compliant is a really difficult one to actually pin down. This is why the capture and containment of firefighting foams is of particular importance. Reduction of chemicals getting out into the environment is key, as it always has been, but especially now moving forwards. So we've talked about the new C8 PFAS legislation, and we expect this C6 regulation to actually come in around the 2021 date, which will take effect in 2023. Now, it's not just Europe that is taking a harder line on fluorinated compounds. The US is also doing so as well. So at the moment, whilst this is being recorded, we have President-elect Biden. He will obviously be President Biden by the time you're watching this. Now, he'd said during his election campaign that he will actually list PFAS, so all PFAS, as hazardous substances, which will legislate cleanup under the Safe Drinking Water Act. Now, the Trump White House had a very different position on this. They allegedly suppressed a PFAS report back in 2018 because it would have caused a public relations nightmare. In 2019, during a Senate inquiry, DuPont actually called for PFOS and PFOA to be listed as hazardous substances. And again, the Trump White House threatened to veto a bill that proposed exactly that. And that's the sort of movement that we're seeing now with Biden coming in, is that sort of hardening, if you will, with regards to PFAS, especially the PFOS, PFOA compounds. But we already know that the US EPA is investigating the C6 version, PFHXA, and is due to report in 2022 if that should be listed as hazardous as well. So it's not just America that's taking a much harder line on the use of fluorinated chemicals in firefighting foam. The European Union is also moving down that route. Now, this was written in a communication from the European Commission to the European Parliament and really demonstrates where they're going with this all PFAS regulation. So whatever's left over, if you will, from the C6 legislation that comes in will be captured by the all PFAS legislation when that comes through in 2025. Now, the European Green Deal stretches forwards through to 2050 with the chemical plan and things like that that goes with it. Obviously, firefighting foam is front and center of the conversation at the moment, but there's all sorts of other chemicals and compounds that are going to be reviewed going forwards. And this will have a massive impact on firefighting foam manufacture and use throughout Europe. So what does it actually mean when it says essential for society? Now, this phrase isn't actually defined in law. There is no legal backdrop to this. So this is a judgment call. And this is exactly what's being discussed at the moment by regulators and various different user groups. But what does it actually mean? So firefighting foam is, of course, essential. So we know that oil floats on water, and we know that bubbles float on fuel. So we know that bubbles need to be there. So the real question is the use of fluorinated compounds, the use of PFAS foams, is that the essential use or not? And that's exactly what end user groups and regulators and things like that are talking to at the moment. So how will they know? How do they know which situations can transition to a fluorine-free and which ones need to retain those PFAS products? Well, the European Foam Manufacturers Association, eurofeu, published this guidance document earlier this year, which actually went through various different uses. You can see through from municipals and aviation, military, oil and gas and chemical, to actually look at whether they can transition and how difficult that transition might be. So let's take a couple of them in more detail. So municipal. The municipal use of firefighting foam is pretty much 100% dispersive, and that doesn't fit with the legislation and where it's going in the future. So that they could actually transition relatively easily to some of the high-performing fluorine-free products that are on the market today. Different sectors might need a slightly different approach. So the chemical industry, for example, has some pretty exotic chemicals that might need to be tested with any kind of product going forwards, whether it be fluorine-free or whether it be a replacement C6. Oil and gas, some installations might be fairly simple to transition, so tanker loading racks and things like that, whereas large-scale 100-meter diameter crude oil tanks might be more complex going forwards. So it's very much a sort of a pragmatic approach, if you will. So as far as testing goes, there's lots and lots of testing that's been done in the recent past. So actually looking at some test work that was done by the NFPA committee, Jensen Hughes Associates over in the US, they won a significant contract to actually look at the efficacy of fluorine-free foams going forwards. That test program cost a considerable amount of money. They conducted 165 fire tests in total and generated this final report, which went up to 92 pages in total. The really, really important thing is that it comes down to 6 conclusions. Now, this is the third conclusion in the report. And basically, this sort of sums it all up. Fluorine-frees are not a drop-in replacement for the fluorinated products. However, some can be made to work as effectively as an AFFF with proper testing and design. And that is key going forwards. Now, the other conclusions are equally as interesting and important. They don't really generate new knowledge, but it is a really important set of conclusions. So the first one, industry are still learning about fluorine-free foams. I think that's a really important one. As manufacturers research and develop new products and launch new products, industry groups, end user groups and things like that are looking to test them and understand the real limitations. And that's an important one going forwards. I think we're all constantly learning. The second one, capabilities vary tremendously between different formulations. So some manufacturers have got particularly high-performing products, where other manufacturers might have sort of the lower end. Now that's exactly the same when it comes to fluorinated products. There's some good C6s and there's some bad C6s. And that's exactly the case when it comes to fluorine-frees. We've covered that third one off about the proper testing and design. The fourth one there, deploying the fluorine-free foams within their listed parameters and with their listed hardware. Now there's lots and lots of testing out there now which can actually be used to help the deployment of these products. So there's lots of information with foam chambers, rim seal pourers, whether it be foam water sprinklers and mobile monitors. And that data can be used to actually assess the deployment within those different market sectors, within those different uses. Now all of the products that were tested by Jensen Hughes were all non-film forming fluorine-free products. So they are dependent on the foam blanket. So expansion ratio is a really important factor. Now, again, some fluorine-free foams will have good expansion ratios in poor conditions, whereas other ones might really struggle. So actually not classifying them as a class is actually really, really important. Every single one is slightly different. The fuel type, I would tweak this one slightly. Where it says that it's not a variable not covered in our listings, I would suggest it's not widely understood. So there's lots and lots of different chemicals out there, but it's very easy to test a few of them and start drawing conclusions and minimum application densities and things like that for the various different products. Excuse me, both hydrocarbons and polar solvents. So it's a good set of conclusions. So what does fluorine-free foam actually mean to you? So the word fluorine-free foam can conjure up all sorts of different things within people's minds, but there is actually no definition of fluorine-free. So EN 1568, UL 162 don't actually have a definition for what fluorine-free foam is. Largely they're referred to either synthetics, fluorine-free, alcohol-resistant fluorine-frees, etc. So the PFAS products that we're moving away from, we know that they've got an element of persistence in the environment, but what about the fluorine-free foams? Is it possible to have a fluorine-free foam that still leaves behind that element of persistence? So I think there's a real need for fluorine-free to actually be defined going forwards so that people can understand what they're buying. Now, how do users avoid buying a product today that could actually be banned tomorrow or bring some kind of problematic use going forwards? So what does it all mean? So we know that the fluorinated firefighting foams, they can be listed as readily biodegradable. But they still carry with it that element of persistence. We know that one manufacturer brought forward some products that were fluorosurfactant-free foams, but still contained some fluoropolymers. That wasn't us, that was elsewhere. So there's a lot of issues with various different naming conventions. All of the standards, as I mentioned, the ENs, the UR162s, NFPA and things like that, still don't have an actual definition for what a fluorine-free foam is. So what I think the industry needs to do going forwards is actually come up with this definition of a non-persistent firefighting foam, or 100% biodegradable. And that's actually quite a difficult thing to do. There's a lot of research being done by the US Department of Defense at the moment using various different silicon-based surfactants, using various different siloxanes. There's also some patents by large companies. There's a lot of research that was done in Europe a few years ago looking at silicon-based products. As far as I know, none of them actually hit the market yet, but that'll remain to be seen. Some siloxanes are already listed under Canada's persistence, bioaccumulative and toxicity list, and some of the organosilicons have actually been found to be toxic to bees. So how do customers, regulators, end users, that sort of thing, know which products are inherently safer and which could be a regrettable substitute moving forward? We're going to go through the C8s, the C6s and the C4s with PFAS. Does that mean we're going to go through the D3s, D4s, D5s with the silicon products as well? So one of the tools available is actually called Green Screen. So what Green Screen does is it looks at all of the ingredients within the formulation, but it also looks at all of the impurities that could come with it as well. So this is everything from unreacted product, from the raw materials that we buy in, to actually blend into finished firefighting foam concentrates. Now what Green Screen does is it looks at all of the ingredients and the impurities and then grades them against 23 different endpoints. So this could be things like carcinogenic, reproductive toxicant, and things like that. It also looks at fate and transport, so aquatic toxicity, biodegradability, and things like that as well. So these 23 endpoints, you then get a product score, if you will, and if it passes, then it can be Green Screen certified. Green Screen certified products are tested to be fluorine-free. They're tested for various different PFAS to try and understand what they're if there's any contamination that has got in through the manufacturing process. Now all of the Green Screen listings are available on their website. This is completely independent. It's a non-profit organization over in the US. And what that means is that procurement specialists, end users, customers, they can actually go to the website to see if the products are actually listed as a safer alternative. Now manufacturers can also use this tool to pre-screen chemicals before they actually formulate and release products. Now the important thing with this is that it actually negates the need for a full formulation disclosure. By being able to rely on somebody else's assessment, an independent organization, to make sure that it is a safer alternative, helps with that foam selection. So one of the key findings from the NFPA report was to not group all of the fluorine-free chemicals, all of the fluorine-free foams into one group. There's some high-performing ones and there's some lower-performing ones, and that's completely to be expected as formulations develop going forwards. So Angus Fire's product is Respondol ATF. It's an alcohol-resistant product that can be used on hydrocarbons, polar solvents. It can be used on Class A as well as the flammable liquids. It's got various different listings and approvals, obviously under EN and UL and Last Fire and those sorts of things. And it could be considered as a viable alternative for many of those different uses that we saw before in the eurofeu report. Now what that means is that we've got a lot of test data. There's a lot of significant fires that have been run using Respondol, whether they be large or whether they be small. So some of the sprinkler testing that we've done, some of the foam chamber testing, some of the rim seal tests, there's a lot of test data that can actually support a transition, whether it be from fluorinated to fluorine-free or a new system as well. Now the most important thing through all of this is that any foam that is bought should be bought to meet the site-specific needs. So whether this be for vapor suppression, whether it be for fire performance, whether it be for environmental purposes, whatever the key driver is for that site or facility, then it's important that that product is bought. Now, there may be situations where fluorine-frees aren't suitable. There may be certain chemicals or compounds where there just isn't any test data to justify or support the transition to fluorine-free. And in those situations, it's important that sites actually still have access to the fluorinated products that are listed with their systems and satisfy their insurance companies. So understanding those site-specific needs, whether it be on a facility basis or a single asset, a single fire protection system basis, is really, really important front and center. So as part of that, and to try and support that transition, Angus Fire has got a full transition pathway available. Now you can see here the graphic on the left-hand side. This is our stage gate process. So this process takes the asset or the facility through that transition process from the beginning right to the end. Now what we can do in using this is we can actually put together some cost drivers. We can understand where the pinch points might be, within any transition going forwards. And what that does is it serves to inform the facility on how they could manage the transition, but obviously set the budgets and things like that going forwards. The second image we call the waterfall, and this looks at the impact of change on the entire system. So it's not just taking a foam out and putting a foam in. We need to look at the viscosity, the orifice plate, the different proportioner, and then any downstream impacts that might have on discharge devices, but then also any upstream impacts that might have, such as storage tanks and pipework and things like that. The next graphic is how we work with the team. So how Angus Fire would work with your local service provider, your local maintenance engineers, your engineering department, your fire protection specialists, first responders, mutual aid, things like that, but also the EH&S, the environmental health and safety. So trying to understand when we're transitioning from a fluorinated to a fluorine-free, or from a C8 to C6, how clean is clean? What is the decontamination protocol to move from one to the other, and how would that be managed? Now Angus can work through that entire process with the team and actually help with that transition. This process has been rolled out with various different oil companies, as well as chemical facilities and other industrial sites. The graphic on the right, that of course is the full documentation pack that goes with it. So with any kind of change out like this, there's a tremendous amount of detail that needs to be covered off and understood. And with this entire pathway, this manual manages to bring all of that together and sort of document that management of change process. So all of the key observations are noted in there, any of the key assumptions and things like that as well as the options available to the site, depending on the products, the application techniques, and things like that. So that's it for today. Just a final summary, or if you will, final few words. Obviously, we're seeing a massive shift in legislation, both in the European Union and across over in the US at a federal level. The C8 PFAS legislation that's coming in, in the EU, the new obligations that have been put onto end users. So any foam stock over 50 litres of foam now has to be tested and may have to be declared to your regulatory body. So this is a significant new burden that's been placed on end users. The C6 PFAS legislation, which is going to, be signed next year and come into effect in 2023, and then the all PFAS legislation, which is due to kick in 2025. So there's a lot going on with regards to new burdens and legislative frameworks that are being put out there. Reducing releases to the environment is obviously paramount, not just for the C8s, which is obviously now written into law, but obviously for the C6s, but also for the fluorine-frees. Any kind of product should be captured and contained and tested before it's released. Obviously the C8s, the C6s, because they contain those PFAS compounds, have to be sent away for high temperature incineration. So capturing containment is a really, really key focus going forward. Understanding what's actually in the product, fate and transport and things like that is really important. So using tools like green screen can be a really helpful indicator for procurement specialists and things like that. And existing engineering systems can be converted. So again, Angus Fire has done this before in many different countries now across the world, and actually looking at how to scope that out. So using our framework, using the transition model to actually build together that budget, but then also the actual conversion timeline and the execution. It's really important to start that process with your destination. So how clean is clean? What is the decontamination protocol when moving from a C8 product to C6 or moving towards a fluorine-free? System listings are available, so Respondal has got a tremendous amount of UL 162 listings on various different fuels, various different devices, with both freshwater and seawater going forwards. So there's a tremendous amount going on in the industry at the moment, and I would encourage you to speak with lots of different people in the industry, different user groups, different manufacturers, to try and understand the legislation that I've been through today. There's a lot of information that's contained within this presentation, so please do feel free to watch it again. If you've got any questions at all, please click on the live chat or whatever it's called and drop a message through and we'll come back to you. If you're watching this on catch-up, then there won't be a live chat function, but you can drop me an email or you can get in touch through the normal channels. So I'd like to thank you again for your time today. Like I say, any questions, please do reach out, please do get in touch, and have a good rest of your day.